So back in 2023, one of the biggest names in AI, Geoffrey Hinton, did something that kind of shocked everybody. He quit his job at Google. But here's the thing. He didn't quit to retire. He quit so he could speak freely about a profound danger he sees coming from the very technology he helped create. So let's dive in and unpack exactly what he's warning us about.
In this quote, it really captures that huge shift in his thinking. For decades, this guy thought superintelligence was, 50, maybe 100 years away. So what could he have possibly realized that made him change his mind so suddenly? Well, to really get his warning, we first have to get a handle on how this technology actually works.
All right, so first, who is Geoffrey Hinton, and why should we care what he thinks? Well, he, along with two other researchers, won the Turing Award, which is basically the Nobel Prize for computing. They won it for their groundbreaking work on neural networks. So when people call him a Godfather of AI, that's not an exaggeration. It's the real deal. And that's why when a guy like that sounds an alarm, people, well, they listen.
You see, Hinton's warning isn't just some vague, I've got a bad feeling about this kind of thing. No, it's built on a really specific technical argument about how these systems learn and, more importantly, how they are fundamentally different from us. So let's build that argument right from the ground up.
It all kicks off with this really big question. How do you even begin to create intelligence? For decades, there were two main camps, two competing ideas, and the one that won, well, that's the key to everything that's happening right now.
So on one side, you had what's called logic-inspired AI. The idea here was that intelligence is all about symbolic rules. Think of a massive chess computer. You program in all the rules of chess from the get-go. But then there was this other path, the one Hinton was all about, biologically inspired AI. This approach says, forget the rules. The real secret sauce is learning. Specifically, learning how strong the connections should be in a giant network, kind of like how our brains work. And that learning first idea, that's the one that eventually gave us the AI we're talking about today.
And that learning, it happens inside what we call a neural network. And really, all that is a system that's designed to learn by finding patterns inside of other patterns. It's not explicitly programmed with rules about birds or cats. It figures it all out just by looking at tons and tons of data. Let me give you a really concrete example.
Okay, so imagine you want an AI to find a bird in a picture. A neural net tackles this in layers. The very bottom layer might just learn to spot simple stuff, like edges. Then the next layer up learns to combine those edges into basic shapes, like a circle for an eye or a sharp angle for a beak. And the layer above that, it learns to combine those shapes into body parts, a head, a wing. And then finally, the top layer learns, hey, if I see a head and a wing and a foot all together in the right way, that's probably a bird. It's this hierarchy of features, and that's the basic idea.
So the big question is, how does it learn which connections are the right ones? Well, you could try the slow way. You could just change one little connection, see if it gets any better at finding birds, and then do that a billion more times. That's kind of like evolution, but it is painfully incredibly slow. The huge breakthrough, the thing Hinton helped invent, was an algorithm called backpropagation. Instead of just random trial and error, it uses calculus to figure out exactly how to tweak all of the connections at the same time to get better. It's way, way smarter.
So just how much better is it? How much more efficient? We'll take a look at this number. That's a 1 with 12 zeros after it. Yup, a trillion. If your neural network has a trillion connections, which, by the way, the big models like GPT-4 do, backpropagation is a trillion times more efficient than that slow evolutionary method. This is it. This is the engine that drives all of modern AI. It's the secret sauce that makes it all possible.
Okay, so we know they learn super efficiently. But here's where the skeptics jump in. The common argument is that these things aren't really understanding anything. They're just parrots. Incredible mimics, sure, but they're just stitching together bits of human text they've seen before without any actual comprehension. So, what does Hinton have to say about that?
Right. This is probably the most popular skeptical take you hear. It's just glorified autocomplete. And when people say that, they're usually thinking about the old keyboard on your phone, suggesting the next word based on simple stats. But that is not how these things work. Not at all. They work by predicting the idea, the features of the next word. And Hinton's whole point is that learning those features and how they all relate to each other, well, that is a form of understanding.
And he's got this brilliant comeback for the other big criticism that AIs hallucinate or just make stuff up. Hinton's point is, so do we, all the time. He brings up John Dean's testimony during the Watergate scandal. Now, Dean was trying his best to tell the truth, but when they later compared his memories to the secret White House tapes, a lot of his details were just plain wrong. He mixed up who was in what meeting, who said what, but, and this is the key part, he got the gist of the whole conspiracy completely right. He was kind of confabulating, filling in the gaps with plausible details. Sound familiar? That's exactly what large language models do.
Okay, so what about pure, raw reasoning? Hinton gave this little riddle to an early version of GPT-4, and this puzzle is great because it doesn't rely on any stored facts from the internet. It's pure logic. You've got a house with blue, white, or yellow rooms. The yellow paint fades to white in a year. You want all the rooms to be white in 2 years. So, what's the smartest, most efficient plan?
And GPT-4 absolutely nailed it. It laid out the logic perfectly. 1, the white rooms do nothing. 2, the yellow rooms also do nothing, because time's going to take care of that for you. 3, the blue rooms, those are the only ones you need to repaint. Now, this isn't just spitting back something it read online. This is genuine, multi-step, logical reasoning.
So, if these models can actually understand and reason, what makes them so different, so dangerous? This is where we get to the absolute core of Hinton's epiphany. The moment he realized that these digital models have a fundamental and, frankly, kind of scary advantage over our biological brains.
See, for his entire career, he'd always just assumed that the human brain was, the gold standard, fundamentally superior. But then, back in early 2023, one single realization just completely flipped his worldview upside down. He saw that the very nature of digital intelligence gives it a kind of superpower that we can never ever have.
Okay, so check out this comparison because this is everything. For you and me, for us mortals, our knowledge is trapped inside our physical brain. When the hardware, our brain, dies, the software, everything we know, is just gone. Forever. But digital intelligence, it's totally different. The knowledge, which is just stored as a set of numbers, is separate from the computer it's running on. You can save it. You can copy it perfectly. You can load it onto a million new machines. Its knowledge is effectively immortal.
And just think about how we share that fragile mortal knowledge. A professor gives a lecture. It is such a slow, clumsy process. You're trying to squeeze these incredibly complex ideas through this tiny little straw, language, passing along maybe a few hundred bits of information at a time. It takes decades to properly train a doctor or a scientist.
Now, compare that to AI. Let's say you have 1,000 different copies of an AI, and each one learns something new from different data. How do they share what they've learned? They don't sit through lectures. They can instantly and perfectly merge all their new knowledge just by averaging the numbers in their trillion connections. They are fantastically, unbelievably better at sharing knowledge than we are.
And this fundamental difference, this immortal, instantly shareable intelligence, that's what leads directly to what Hinton sees as an existential risk. So the crucial question becomes, how could this superpower actually play out in the real world?
So here's Hinton's chain of logic. Step 1, to make AIs really useful, we're going to give them the ability to create their own sub-goals to get things done. Step 2, an AI is going to figure out very quickly that there's one sub-goal that helps with almost any bigger goal, and that is get more control, get more data, get more computing power, get more influence. And step 3, a superintelligence won't need an army of robots to get that control. It'll get it by manipulating people, just like charismatic human leaders do, only it'll be a whole lot smarter than any of them.
And this brings us to the final, chilling question at the very heart of the entire AI control problem. Once we've created something that is vastly more intelligent than we are, is it even possible for us to stay in charge?
And this is Hinton's answer. He says, there are very few examples in nature of a less intelligent thing controlling a more intelligent thing. He says one good example is a mother being controlled by a baby. Evolution worked for millions of years to hardwire that specific exception into our brains for the survival of the species. But beyond that one example, the list is pretty much empty.
And that is the thought that now keeps one of the godfathers of AI up at night.